Alright guys, in this video we'll be looking at transformations. More specifically, we'll be looking at transformations on our square root parent function. At this point we've already looked at transformations on both the quadratics and our linear functions. Now we're going to apply those same transformations to our square root function. So let me remind you of a couple of things here. First of all, a. When we're multiplying our function by some value, one of three things can happen here. First of all, if that value in front of the square root, is a number greater than 1, such as a 2, 3, 4, what's going to end up happening is we're going to have a vertical stretch. We're going to stretch out our graph vertically. Now if that value is something between 0 and 1, such as a 1/2 or a 0.5, a 0.6, a 1/3, then what we're going to do is we're going to vertically compress that graph. And then finally, if a is a value that is less than 1, actually less than 0, meaning that it's a negative number, then we're going to end up with a reflection over the x-axis. Alright, so again, one of those three things. And actually, we could also have a reflection along with a stretch or a compress. So that's what value of a does. Now let's talk about the h, the number inside of our square root. Now, if we're adding a value to x, what we're going to do is we're going to move the graph to the left that many units. If we subtract h from x, we're going to move to the right that many units. And I'll show you some examples here in a little while. And then the k. K is that value on the outside of the square root. When we add, we're going to move up that many units. And when we subtract, we're going to move down that many units. Alright, so that's what our a, our h, and our k does. Alright, so now we're going to look at some examples and see how this works. Alright, so here's our first example. We're working with the function f of x equals the square root of x plus 3. At this point I have the parent function graph. That's what you see here. And what we're going to do is we're going to take this parent function and we're going to perform the transformation that we're given. Now notice here we have a plus 3 on the outside of our square root, which means we're going to move this graph up 3 units. So what I'm going to do is I'm going to take a couple of points that are on this graph and we're going to move them up 3 units. So I'm going to start with this point right here, origin, 0, 0. And I'm going to move that up 3 units, which would put me right here. I'm also going to move this point 1, 1. I'm going to move that up 3 units, which would put me right here. And then I'm also going to move this point right here up 3 units, which would put me right here. So when I connect these points, I now end up with this new graph. So this graph is the function f of x equals x square root of x plus 3. All we did was translate the graph up 3 units. So down here at the bottom where it says how does this function compare to our parent function, well, we moved it up 3 units. And notice by moving it up 3 units, our endpoint, which is this point right here, is now at the ordered pair 0, 3. It's no longer at 0, 0. Alright, let's take a look at the next example. Here we're working with the function f of x is equal to the square root of x minus 3. Notice how we have a minus 3 on the outside of our square root, which is telling us that we need to take this parent function and move it down 3 units. So just like I did a second ago, we're going to take this point right here, we're going to move it down 3, which would put us right here. Then we're going to take this point 1, 1, we're going to move it down 3, which is going to put us right here. And we're also going to take this point 4, 2, and we're going to move it down 3 units, which would put us right here. So when we connect these points, notice it's still the same graph. All we did was slide it down 3 units, or translate it down 3 units. So again, down at the bottom, how does this function compare to the parent function? Well, we translated it down 3 units. And again, notice our endpoint, this point over here, is now at the ordered pair 0, negative 3. Alright, next example, we have the function f of x is equal to the square root of x plus 3. However, notice this time the plus 3 is on the inside of our square root. So this time what we're going to do is we're going to translate this graph 3 units to the left. So I'm going to take that point 0, 0. We're going to move it 3 units to the left, which would put us right here. I'm going to take this point 1, 1. We're going to move it to the left 3 units, which would put us right here. And I'm also going to take this point 42, move it 3 units to the left, putting this right here. So when I connect these 3 points, notice that I still get the same graph. All we did was translate this graph 3 units to the left. So down at the bottom, how does this graph compare to our parent function? We translated it 3 units to the left. Alright, so left 3 units. And notice by moving it 3 units to the left, our new ordered pair for our endpoint is at -3, 0. Number 4, we have the function f of x is equal to the square root of x minus 3. Again, this minus 3 is inside of our square root, which means we're going to translate this graph 3 units to the right. So I'm going to take this point, we're going to move it 3 units to the right. I'm going to take this point 1, 1, move it 3 units to the right. And I'm also going to take this point 4, 2, and we're also going to move that to the right 3. So when I connect these points, I get this new graph. So to get this new graph, all we did was move the graph 3 units to the right. So right 3 units. And by moving it to the right 3 units, notice that our new endpoint is at 3, 0. Alright, let's try another one that's a little trickier here. We have the function f of x is equal to the square root of x plus 4 with plus 2. Now notice the plus 4 is inside of our square root and the plus 2 is on the outside of the square root. So let's be careful here. The plus 4, because it's inside the square root, we're going to move to the left 4 units. That plus 2 is telling us that we need to move up 2 units. So we're going to take each of those points and we're going to move them left 4 and then up 2. So I'm going to start with this point at the origin. We're going to move left 4, but then we're also going to move up 2, which would put us right here. Left 4, up 2. Let's do the same thing with this point 1, 1. We're going to move left 4, and then we're going to move up 2, which would put us right here. Alright, let's do one more and take that point 4, 2. We're going to move to the left 4, and then we're going to move up 2, putting us right here. So if I connect these points, this is my new graph. So I had to perform 2 different transformations, left 4 and up 2. So down at the bottom, how does this graph compare to our parent function? Well, in this case, we moved left 4, and we also moved up 2. And by doing that, our new endpoint is now at -4, +2. Alright, number 6, we have the function f of x is equal to the square root of x minus 2 minus 1. Alright, so the minus 2. The minus 2 is going to start us off by moving us to the right 2 units. And the minus 1 is going to move us down 1 unit. So let's take each of these points and let's move to the right 2. And then we're going to move down 1, which would put me right here. Do the same thing with this point 1, 1. We're going to move to the right 2, down 1. And then finally take this order pair 4, 2, and let's move that to the right 2, down 1. So our new graph looked like this right here. So again, all we did was take the parent function and translated it 2 units to the right and 1 unit down. So how does this compare? Well, just as I said, we moved it to the right 2, and then we moved it down 1. And by doing this, of course, we have our new endpoint, which is going to be at 2, -1. Alright, next function we have is f of x is equal to 2.5 square root of x. So let's see here, the 2.5. The 2.5 is going to stretch this graph vertically. Now this is a little trickier to stretch the graph here, guys. So what I did was I took each of those 3 points that we've been working with, 0, 0, and I've put it in my table out here to the right. I also have the ordered pair 1, 1. I've got that in my table as well. And I also have that ordered pair 4, 2 in my table. So what we're going to do in order to stretch this graph out vertically is we're going to take the y values, which as you can see in my table are 0, 1, and 2, and we're going to multiply those y values by 2.5. That's the number in front of the square root. That's how much we're going to stretch it out. So let's start with the 0. If I multiply 0 times 2.5, that's still a 0. If I multiply the next y value, the 1, if I multiply that 1 times a 2.5, I get a 2.5. Now I'm looking at that last y value, which is 2. If I multiply 2 times a 2.5, I end up with a 5. So what I did here was I took all the y values and I multiplied them by 2.5. That's our stretch factor. That's how much we're stretching it out. So at this point I have some new ordered pairs. So I've got the first ordered pair 0, 0. So I'm going to go ahead and plot that point 0, 0. I also have this new point 1 and 2.5. So I'm going to find 1 and 2.5, which would be right about there. And then that last ordered pair has now become 4, 5. So I'm going to look for the ordered pair 4, 5, which would be right here. So when I connect these dots, you'll notice that I've now taken this parent function and stretched it vertically. Alright, so down there at the bottom when it says how does this function compare to the parent function, well, we vertically stretch the graph. There's a vertical stretch here, and the vertical stretch, the factor of that vertical stretch is 2.5. That's how much we stretched it out. Obviously, the bigger that number is, the more you're going to stretch out your graph there. By the way, the endpoint. Notice the endpoint is still in the same spot. It's still at 0, 0. All right, let's take a look at number 8. Function we're working with here is f of x is equal to 0.6 square root of x. Now, because the number in front of that square root is a number between 0 and 1, this time what we're going to do is we're vertically compressing the graph. So we're going to treat this much like number 7 here. We're going to take those y values again, but this time we're going to multiply those y values by 0.6. So again, I've got my table over here to the right. So I'm taking the first y value, which is 0, and we're going to multiply that by 0.6. So 0 times 0.6 is still a 0. I'm going to take the next y value, which is 1. We're also going to multiply that by 0.6. So 1 times 0.6 is 0.6. And then we're going to take that last y value, 2. We're going to multiply that by 0.6. So 2 times 0.6 is 1.2. So what I've done here is I've created some new points, some new ordered pairs. So let's go ahead and plot these points. The first one is 0, 0. So I'm going to put a point at 0, 0. The next point or next order pair is 1 and 0.6. So I'm going to find 1 and then 0.6, which is somewhere around there. And the next point is 4 and 1.2. So let's come over here and find 4, 1.2, just slightly above the line. Connect these points. And we've got our new graph. Notice how we've taken that parent function and we've compressed it. It's kind of like somebody coming over and stepping on that thing and squashing it down. Alright, so here we have a vertical compress. Alright, sometimes you may also hear that referred to as a vertical shrink. Same thing. Endpoint. Notice the endpoint is still at 0, 0. Number 9, we have the function f of x is equal to negative square root of x. Alright, so that negative sign. The negative sign is going to give us a reflection over the x-axis. So what we're going to do is we're going to take this parent function and we're going to flip it over the x-axis. So that first point 0, 0, since it's on the x-axis, it's going to stay on the x-axis. This point 1, 1 is on the top of the x-axis, so what we're going to do is we're going to move it to the bottom of the x-axis, which would put us here at 1, negative 1. That ordered pair 4, 2. Notice how it's above the x-axis, so what we're going to do is we're going to move it below the x-axis, which is now putting it at 4, negative 2. So when I connect these points, I get my new graph. So notice what we've done is we've flipped it over the x-axis. So again, what we have here is a reflection over the x-axis. Notice how the endpoint is still at 0, 0. So all that negative sign does is flip it over the x-axis. Alright, let's do one more here, but let's try something a little different. This time what we're going to do is we're going to give a graph, and we're also going to state the transformations. And from that graph and transformations, we're going to see if we can come up with the equation that goes with this graph. Alright, so first of all, we've got our parent function, and the first thing it says here is we're reflecting it over the x-axis, which is why this graph is upside down. Along with that reflection, it says we're also going to translate it up 5 units. Alright, so when we write our equation, we must include these two things. We got to show the reflection, and we also got to show that we're moving it up 5 units. Alright, so here we go. Let's start with f of x. Now, because I need that reflection over the x-axis, I'm going to start off with a negative in front of my square root. Of course, we're taking the square root of x, but we're also moving this graph up 5 units. And because we're moving it up 5 units, we're going to have to add 5. And when I say we're adding 5 on the outside of the square root. Adding 5 inside the square root would move the graph to the left, and that's not what we're doing here. We're moving it up 5. Therefore, the equation for this graph is f of x equals negative square root of x plus 5.